let's go here. So there are one of the big focuses in this class is looking at things from several different perspectives. So what's important for you guys to understand is that the equation and the graph and the table are all related to each other, right? So sometimes we might look at functions as tables. We might look at them as graphs. We might look at them as the equations themselves, and all of those are related to each other, and changes in one are going to affect changes in the other. So here we have an example where they have given us a table, and it says the table of a function and its graph are given below. Given this information, fill in the table for the inverse function and graph it. So for that, inverses for tables are super duper easy because this is your x column, this is your f of x, or like your y coordinate column. All you got to do is switch them, right? So tables are really easy for this. So if I've got 1, 2, 3, 4, 5, and 2, 4, 9, 4, 12, I'm just switching the columns. So 1, 2, 3, 4, 5 will go over here and become my y coordinates. And then 2, 4, 9, 4, 12 will be our x coordinates. Now, the reason I put the graph here is because another thing that we need to think about is if our inverse is also going to be a function. Okay? So this is our original f of x is a function. Because if we did the vertical line test here, we only hit 1 point everywhere on the graph. So this is a function. So I also want to know if the inverse is a function. So in red over here, I'm going to graph my new points, my inverse points. So I've got the point 2, 1, which would be right here. I've got the point 4, 2, which is right here. I've got 9, 3, right here. I've got 4, 4, which is right here. And I've got 12, 5, which falls right here. Okay? So looking at those red points are my f inverse of x. Are the red points a function? Okay, I'm seeing some of you shake your head no. What makes it not a function, Emma? What? When we do vertical line test, right here, we got 2 points that touch. Now, I don't really want to graph everything that I come across, unless maybe the graph is already there for me. How could I tell that before I had to graph it? What? Okay, look on the x for which function, the original or the inverse. So on that inverse, I could see that that x was repeated, right? That 4 right here and 4 right here, that tells me no, that's not going to be a function. Could I do it without even looking at the inverse? Could I do it by looking over here at the original? Could I tell right here that the inverse would not be a function? I know when I do an inverse, x and y flip, right? So if I look at the original and I see the y's repeat, that tells me f can be a function, but the inverse is not going to be, right? Because they're going to switch and those are going to become my x's. So you could even do it without having to actually switch the x's and the y's. But in this case, let's make ourselves a note right here. So in this case, if we want something to be a function and its inverse to be a function, then we cannot have repeated y values because they will become repeated x values when we switch, right? What type of function is that where we don't have any repeated x's or y's? It's a special kind that we talked about. It is a, say it, Cannon, is a one-to-one function, right? Because it'll pass vertical and horizontal line test. That would mean the x's and the y's both are not repeated. So let's put ourselves a little note right here for the inverse of f of x to be a function. F of x must be 1, 2, 1. So if your original is a one-to-one function, your inverse is also going to be a one-to-one function for that. If your original is not a one-to-one function, then the inverse is not going to be a function for that. Okay, questions? Okay, so graphically, this is going to be really important for us because it is a very good way to check your work. So when we get to doing these algebraically, it is a very good way to check your work. I have two functions graphed right here, and they're asking me if these are inverses. And we don't have the equations of these. I could look at some points, and I'll do that here in a second. But we earlier said, and we can write it here again, if two functions are inverses, they are symmetric about the line y equals x. Okay, we put that on an earlier slide as well. What's symmetry mean? What does it mean if something has symmetry? That's a term that you learned like way earlier, and then it might show up in things like art class or other places as well. If something's symmetric, what does that mean? What, Samara? It's even on both sides, right? You can like fold it in half. They say like if your face is very symmetric, you're a more beautiful person. So like, I mean, definitely if you had like a eye drooping way, like, you know, if your face is very symmetric, it makes you more beautiful. So they say. But we can fold it in half and the two sides match up, right? The line y equals x. Let's talk about that one a little bit. Make sure you guys know what the line y equals x is. So y equals x. If we think about y equals x, it is going to be a line. It's a y equals mx plus b line, right? What is the slope of this line? What number is in front of that x? It is a 1. So we have a slope of 1 on this line. There's not a y, there's not a number behind it. There's no b. What number could I add right here? I could add a 0 and it'd still be the same, right? So it has a y-intercept at 0, so that means it goes through the point 0, 0. And it has a slope of 1. So if we draw that in here, you're just going to put a dot at 0, 0, and then you go up 1, right 1. And then you could also go down 1, left 1 to finish out that line. Okay, that's a really important line for us to know what it looks like. So whenever you're doing these problems, if you're given a graph like this where you don't have the equations, you can draw that in. Does this look symmetric? Does it look like we could fold it in half and the two sides would be on top of each other? I think so. Sometimes it's hard to tell. Sometimes it's close. But it'll give you, if it's way off, you know, oh, these are not inverses. You also, if you're not sure, if you need to like a little more assurance here, you can check exact points. So like for example, this graph right here has the point 1, 5. So what point would have to be on my inverse? What do we do with our x's? 5, 1. 5, 1 would have to be on the inverse. There it is. It's on the other line, right? I could check another one. I've got the point right here, -1, 1. So if I switch it, 1, -1 is on the graph. And you could do lots of points if you want, but that sort of is enough. Also, for these to be symmetric, they don't have to cross. But if they do cross, they better cross on the line y equals x, right? If they cross somewhere other than the line y equals x, then they're not symmetric. They don't have to cross, though. They can be sort of like parallel and have like a gap between them. But if they do cross, they're going to cross on the line y equals x. So this is what it's going to look like whenever we have two things that are inverses. And we're going to use this a lot to check our work when we're doing this algebraically, because it's very helpful to make sure we did it correctly. All right. So now we've got these two right here. And it's asking if these are inverses. They do kind of look symmetric, like I could fold something. But we need to, let's draw in that line y equals x. So y equals x, we're going to do here in red. And that is at 0, 0, up 1, right 1. Down 1, left 1. So when I look at that, if I fold this graph in half on that dotted red line, are the two sides of the graph going to match up? They're not. And the biggest thing that you can see right here is these two graphs cross, but they don't cross on the y equals x line. If the graphs cross and it's not on the y equals x line, then it's definitely not. So this would be a no for that. Okay, something you might be asked to do is graph an inverse. And if you are really good, really good, you might be able to put in y equals x and flip these by looking at it. So I know I've got a few of you that are kind of artists out there, some of Mr. Bashir's star students. And a lot of times my kids that are artists can do this by looking at it because they are very visual people that can see things in their mind. I am not much of an artist, and knowing where to flip a point is difficult for me. I can't see it quite as well. So if you're asked to graph an inverse like this, you can always just use the points. So, for example, if I go through this graph and I just pick, like, the points where I hit grid lines, I'm going to just put dots right here. I'm going to pick those points right there. You can make a table if you want, or you can just, I think I will make a table, just to be very clear. So, like, for this, I've got the point -3, 5. This is the point -2, 0. This is the point -1, -3. Then I've got 0, -4. I'll get 1, -3, 2, 0, and 3, 5 for that. So that's the table for the points I'm looking at right now. So if I want to graph the inverse, in fact, let me call this F inverse right here. What have I got to do with my table? Just got to switch those x's and y's, right? So I'm going to have 5, 0, -3, -4, -3, 0, 5, -3, -2, -1, 0, 1, 2, 3. So I'm just going to flip the x's and y's. And so the point that was negative 3, 5, that's this point right here, it becomes 5, negative 3. So 5, negative 3 is right here. It is flipped across that line right there. You can see it's like the same distance away. But to me, that is so hard to do visually, like just knowing where it goes. I can flip things upside down over the x-axis or over the y-axis much more easily, but I have a really hard time seeing this. So I usually do it this way. Then I've got 0, negative 2. So 0, negative 2 is right here. Then I've got negative 3, negative 1. So negative 3, negative 1 is here. Negative 4, 0, right here. Negative 3, positive 1. 0, 2. And 5, 3. And so now you can see it flips this parabola over on its side. That is not necessarily what I would have drawn if I had just guessed at it. In fact, I might should have made you guys guess at it first for that. Yeah, not what you would have done. No, I probably would have sort of flipped it upside down, which would just be reflecting it over the x-axis, which is not what we're doing there. So if you're asked to flip this, or if you have to match graphs, because sometimes you might have to match graphs, because you probably won't be able to ask to graph things by hand, because I usually give everything on the computer, but you might have to match graphs, and you might not have an equation where you can do it algebraically. So you could make yourself a table and just flip it and graph those. Is my inverse a function on this one? It is not. That blue graph right there does not pass the vertical line test, right? We've got repeated x's. Yes, repeated x's right there that cause that not to be a function. Okay, questions so far? All right, let's keep moving. I think I already wrote this down because I forgot it was here. The inverse is a function. That's not worded correctly. The inverse is a function there twice. Take one of those out. The inverse is a function if and only if the function is a blank kind of function. We already talked about this. I wrote a note about it. What kind of function do we have to get an inverse that is also a function? What is it, Zoe? 1 to 1. Okay, and that is a function that will pass both the vertical and the horizontal line test. Okay, so I'm going to pull up Desmos here for this because I know what 8 looks like. I know what 10 looks like. I don't know what 9 looks like very well off the top of my head. And you guys may or may not recognize any of those. But this question is just asking us if the inverses are functions. So we're given the original function, and they're asking us about the inverse. So what we can do is we can just graph the original function. So f of x equals 2/3 x minus 1. And we can look at that graph. Is this graph going to be a 1-to-1 function? Yes, that passes the vertical and the horizontal line test. So if I have a 1-to-1 function, the inverse is also a function. So this one would be a yes. Okay. If we try that next one. That one's a little trickier. Let me show you a trick on Desmos. If you're wanting vertical line test on Desmos, type in x equals 1, and then down here, I think you can do like negative 10 to 10. Actually, I don't even know if I had to type that in. Let me try that again. See, x equals 1. All right, if it'll automatically do it if you hit enter. This puts us a vertical line at 1. You don't have to put 1. It could be any number. X equals 1, x equals 0, x equals 10, whatever. But it'll let us drag that vertical line back and forth if we do that. So let's look. Does this pass the vertical line test? Oh, let me do that. It's definitely okay like here and over here, right? It's right here. It gets a little tricky. Like right there, it looks like it's touching a bunch of times. But if I zoom in, is it actually touching a bunch of times? It's not. What we've got there is called a vertical asymptote. This is still going to pass the vertical line test. So the inverse, actually, I'm sorry, that is vertical line test. So this passes vertical line test. But what else do I have to check? Horizontal line test. So if x equals a number gave us a vertical line, what do you guys think we need to type in for a horizontal line? Y equals a number. So I'm just going to do like y equals 1 and hit enter. And that's going to give me this line right here. Do I pass horizontal line test? It's almost the same, right? Like it gets a little iffy right here. But if I zoom in, am I actually like touching that line more than once? I am not. That's a horizontal asymptote for that. So this one is a one-to-one function. So your inverse would be a function. And our last one here, I've got f of x equals 9 minus x squared. That one's a function. Does it pass the horizontal line test? Nah, that one doesn't pass like almost everywhere. It's got 2 points, right? So that would be a no. Your inverse is not going to be a function for that one. All right, so let's keep moving here. These are my favorite to do. I love doing these. I like just like solving equations algebraically. Anyway, I know some of you feel the same way because when we were doing like absolute value equations, you like that better than all the graph stuff. So if you are with me on that, you might like finding these. Here, finding the inverse of a function. Whenever we're doing this by hand, okay, whenever we have an equation, what we end up doing, right, when we looked at the graph, what did we do with our x and our y coordinates to make an inverse? We switched where they were at, right? So when we had that table, we made all the x's our y's and all the y's our x's. We just switched where they're at. So it works the same algebraically. So what you're going to do is you're going to take the x and the y in your equation and you're going to switch them. So all you're going to do is turn all of your y's to x's and all of your x's to y's. So the y right here becomes an x, and I'll have 2, and then that x becomes a y plus 4. Okay? Then what you want to do is solve that new equation for the new y, right, for where we've got the y. Now, some kids have a lot of trouble with this because it's not like, it is exactly like solving a regular equation, but you don't get a number for your answer. You get a new equation, okay? It seems a little confusing, but in a lot of ways it's actually easier because you don't actually have to add, subtract, multiply, divide any numbers, really. So if I were solving this equation for that y right there, so I'm trying to get that y right there all by itself, okay, what would I need to do first? I would subtract that 4, right? So I'm going to subtract this 4 to get rid of it, and that means I must subtract 4 on the other side. What in the world is x minus 4? Can I do that? I cannot. So it's actually almost easier, okay? You don't have to do it. You just write x minus 4 right here. Kids don't like it because it's got too many letters and stuff in it. But you just write down what you've got. So if you don't have like terms that you can combine, just write it like that. And then you've got 2y. And we are still trying to get that y right there by itself. So whenever I'm trying to get that y right there by itself, I got to get rid of that 2. Jamaja, what have I got to do to that 2? I'm going to divide it. So it's just like solving regular equations. The only difference is you're not getting like a number as your answer. You're getting a new equation as your answer. And it is okay right here. Leave this stuff this way. X minus 4 over 2 equals y. And then the last thing that we do a lot of times is they'll be using function notation. So we'll replace that y with f inverse of x just because they use that function notation instead. A lot of times they will also write the x minus 4 over 2 over here on the right hand side. And so that would be your final answer. Now, we talked about the graphs a lot at the beginning. What we're mostly going to use those graphs for is checking this to make sure we did it correctly. So if we pull up Desmos right here, our original equation was y equals 2x plus 4. Desmos does not do inverse notation. So if you tell it f to the negative 1 of x equals x minus 4 over 2, you get an error right here. Desmos does not like inverse notation. So you can what you can do is you can either just call it y right here, like the step before this, or you can call it f of x or g of x or something like that for that. So if I graph these two, I want them to be symmetric about which line? Was that red dotted line we were putting in? What was that line called? Look back in your notes. It's a line of symmetry. What's the equation for that red dotted line? Y equals x. So type in y equals x. Make sure that it looks like you could fold that graph in half, right? It's not guaranteed. Like if you had like a 3 right here for some odd reason, like it might look close and you might miss it, but if it looks way off, it'll help you catch a mistake that you've made. So when you graph your original, your inverse, and y equals x, that y equals x line should go right down the middle of your graph. It's there. Okay? So that's a way to check. Questions? All right, let's try a couple that are a little bit harder. Right here. So these two start with an f of x instead of a y, but f of x is like your y coordinate. So the first thing that you want to do is switch your x's and your y's. So this f of x, or we can think of it as our y, becomes x. And then we just copy the rest of it. This x over here becomes a y over 2. Okay, here. All right. We are trying to get this y right here by itself. So we need to get rid of the negative 4, the negative 5, and the 2. Fernando, which one do you think we're going to get rid of first? Not the negative 4. It's the 2. Because that whole top part, it's almost like these are in parentheses because the whole thing's been divided by 2. So we got to wait till last to deal with the top part. We're going to get rid of that denominator first. So how do I get rid of a divided by 2? Multiply by 2. That'll cancel out over here. Multiply by 2 over here. Can I multiply 2 and x together? I mean, can I get a number for it? No. But I can just like write 2x right there, right? So I've got negative 4 minus 5y. Again, the y is what we're trying to get by itself. right there. So for this, Sophie, what should we mess with next? We're trying to get that y right there by itself. Not yet. So when we're doing these, we're trying to get the numbers furthest away from the y. We get rid of those first, and then we go closer to the y. So that -5 is right beside the y, so we don't want to mess with it yet. We want to get rid of that -4. How would I get rid of that -4? You got to use opposite operation. We're going to add it. Good. So we'll add 4 to both sides. So I got 2x plus 4. I just have to write it like that because I can't add 2x and 4 together. The 4 does not have an x with it. And then I've got, be really careful here, don't lose that negative. You got -5y. All right, again, still trying to get that new y by itself. So we got one more step here. Hector, I got to get rid of that -5. How am I going to get rid of it? Not add. We got to divide. It's because this can be confusing because it's got that negative in front of it that makes you want to add. But it's right next to the x, which means it's being multiplied by that x. So to undo multiplication, you're going to divide. And you don't change signs for that. You're dividing by -5. So we're ending up with y equals 2x plus 4 over -5. And they usually will switch that back to inverse notation and make it f inverse of x instead of a y. Another thing they might do here is that negative right there that's in the bottom. Whenever you're dividing fractions, you can put the negative in the top, the bottom, or out front. You just can't put it all three places. So a lot of times they'll put the negative out front like this and do 2x plus 4 over 5 instead of putting it in that denominator. Now, if it's one you're like just answering for me, you can do it either way. But if it is multiple choice, you're probably more likely to see this answer choice right here. So this would be our final answer. Okay. To check this, we're going to graph it. So if we go to Desmos here, I'm going to leave that line, y equals x. In fact, I'm going to make it a dotted line. If you hit the gear and then hit this, you can make it a dotted line if you want. That way you remember that's the one you're looking for there. So we got f of x equals -4 minus 5x over 2. And then we got, I'm just going to call it g of x instead of f inverse because it doesn't like that. Or you can call it y equals. And what did we have? We had 2x. Oh, wait, there was a negative out front, wasn't there? -2x plus 4 over 5 for that. So if I look at that, does that look pretty symmetric, like we could fold it in half? I think so. It's at least not like crazy enough for me to throw it out, right? So it looks like we've probably done it right. Again, this is not going to guarantee that you get it right, but if it's way off, like let's say we had a 4 here and a 2 here, I can see like that those two don't cross on my dotted line. So that would let me, oh, I messed up somewhere. That's not right if I see that it's not symmetric there. Okay, questions? All right, I'm going to give you a hint on number 13, and I want you to try that by yourself. This one has a cube in it. How do we undo a cube? What? I heard something that maybe sounded, what did you say, Heston? You're really close. To undo a square, we would square root. To undo a cube, we have to do a cube root. A cube root is like a square root with a little 3 on the outside. So that's good. You're going to need that somewhere in this. Try this problem on your own. I'm trying to get this y right here by itself. When you are solving an equation, whether it is an inverse like we're doing here or whether it's just a regular solving equation like you do, very basic math 1, you start furthest away from that y. That's this minus 2 over here. Richard, what's the opposite of subtracting 2? What will get rid of that? Okay, we're going to add 2. Okay, that'll cancel this out. If I add 2 to one side, I've got to do it to the other side over here. Now, I need to write this whole next line down. Don't skip steps. Don't do it in your head. You've got, over here, can I put x and positive 2 together? They're not like terms. One of them has an x, one does not. So I just have to write it like this, x plus 2. Okay, we're going to have an equal sign. Okay, then we're going to copy down what's left. Copy it down. Don't skip it. Don't do this part in your head. Y'all are getting it wrong. Look at your neighbor and see if they have this line written down right here. And if not, tell them to quit being lazy and do it the right way. Yeah, you might have to, like, go across the street to those neighbors. Okay? All right. We are still trying to get this y right here by itself. So we need to go furthest away from that y, which is this little bitty 3 right here, which is cubing that. What did we say the inverse of the cube was going to be? A cube root. So that means on both sides, I am going to cube root this side, and I must also cube root this side. Okay? Now, the cube root and the cube over here cancel each other out. So on that right side, you only have y plus 1 left. The cube is gone. The cube root of x plus 2 over here, you can't do anything with it. You're just going to have cube root of x plus 2. We're getting really close. The y is almost by itself. So everybody should have this line. Cube root of x plus 2 equals y plus 1. Look at your neighbor. Make sure they've got it. Make sure they're not slacking. Is he slacking? Make sure he's got it. All right. So, again, we're trying to get that y by itself. Okay? The last thing that we have there, Carson, is a plus 1. How do we get rid of a plus 1? Minus 1. Now, this last step can be a little bit tricky because kids want to do it in the wrong spot. So, we are subtracting 1 right here, and we got to subtract 1 over here. And a lot of people want to subtract 1 from that 2. But that 2 is inside of a cube root. Is our 1 inside of a cube root? It is not. We cannot subtract that inside of the cube root. So what that's going to look like is we're just going to have cube root of x plus 2, and then we'll have a minus 1 over here that's on the outside of that root. Okay, so your final answer will look like this. We'll change our y back to f inverse, and we usually put it on the left side. And then we'll have the cube root of x plus 2 minus 1. And I do always copy notes for you, and some of you write bigger. If you don't have enough room to do problems on these, you are always welcome to get a sheet of notebook paper and just do it there if you're having trouble fitting everything in here. So I'm coming around to see that we all have some work, and we got the answer. Okay. That's terrible.
You're saying that I don't work hard for service? Yes. Is there someone that does?
Pay a little attention.
Is there a difference in the two of us? I didn't have it, so I did the keep do, but I didn't do one of these.
Downhill, but it's at least all there. Okay. All right. I'm telling you, please, I beg you, you can't do these if you just write a couple things down, unless you are so good at it that you can do the whole thing in your head. And most of us are not so good at it that we can just do it in our head. Okay? So please, neat work for these. All right, now, a lot of the questions you're going to get are going to look like this. Okay? They're going to be multiple choice questions because it is hard for me to have you type an equation into Canvas, because if you put a space in the wrong place, if you use X when you meant a Y, like it counts it wrong automatically. So I usually do these multiple choice. So let's look at a strategy. Some of y'all really need to pay attention to this strategy because y'all were terrible at the others. The best thing to do for this is to solve it by hand. It's the fastest way. Okay? So if I look at this, this is like my Y. I'm going to change that to an X. I'm going to change my X to a Y. Okay? This one's not that bad. It does have a fraction, which sometimes messes students up. But it's not got too many steps. So when I'm looking at this one, Joey, what's the first thing I need to try to do to get that Y right there by itself? Okay, we're going to add that 4. Okay? Can I put X plus 4 together? I cannot, so I'm just going to write X plus 4. Okay? And then I've got to get rid of that 1/2. Samara, what would I do with that 1/2? Did you say? What would we do? We're going to divide by 1/2. Oh, gosh. I don't know what happened there. It's not me. I mean, maybe it was, but I didn't mean to. Yeah. As I'm fussing at you for your neat work, I've got this stuff over here. All right, so they're not. Notice none of our answer choices look like that. None of us, like, technically, this cancels out. Now we have X plus 4 over 1/2 equals our Y. You are technically done here, but any of your answer choices look like this. They do not. Okay? It is because that is a complex fraction, and they are never going to leave a complex fraction as part of the answer. So, how do I divide fractions? I don't think I haven't taught any of you guys before, have I? I feel like I say this all the time. All the time. Dividing fractions is easy as pie. Flip the second and multiply. Your teacher said that before. I say it all the time. Dividing fractions is easy as pie. Flip the second and multiply. So This is x plus 4. We do not flip it because it's the top fraction. Dividing fractions, easy as pie. Flip the second, so we flip the 1/2, and we multiply. Now, what is 2 divided by 1?
2.
It's just 2, right? So I have got, I'm going to write the 2 first. 2x plus 4. Is that an answer choice?
I figure not.
It's pretty close to B, but is this the same thing as B? No. So which one does it match? 2x plus 8, because if I distribute that 2 right there, I will get y equals 2x plus 8. Okay? Now, when you see yourself having to divide by 1/2, flip the second, multiply. It's the same as multiplying by 2. So if you wanted to do that from the beginning, that would be even quicker there. Now, let's say that you are less than good at this. Okay? And that every time you try this, it falls apart. You also have an option with Desmos. It's not foolproof. Sometimes 2 answer choices look really similar, but it'll at least usually eliminate a few answer choices. So let's look at how we could answer the same question with Desmos instead of by hand. So I'm going to leave y equals x here. I'm going to type in the function f of x equals 1/2 x minus 4. Okay, so that's my, I don't want to do that. Okay, that's my original function. I'm just going to type in answer choices. It does not like inverse notation. You just have to call it g of x or y equals or something like that. So y equals 4x minus 2. Is that symmetric? It is not. A can't be the answer. I'm going to try 2x plus 4. Is that symmetric? It's closer, but notice right here they cross and they don't cross on the line y equals x, so it's not symmetric. So that's not it. If I change it to 2x plus 8, is that symmetric? Yes, that looks good. That should be our answer. If I try x over 2 plus 4, is that symmetric? No, not even close. That's the worst one of them all, right? So that one, I could probably answer that one from Desmos without solving it at all. Solving it, if you're good at it, is your fastest way. Like if you see this on an ACT problem. Graphing it takes longer. But you can always check these with Desmos too if they're multiple choice. Okay, questions? Okay, that was our last. No, we go. Okay, this one. I want you to try this one. Okay. Desmos or solving it by hand. Either one are fine. When you can show me how you got the right answer, it can be by hand, or you can show me a graph on Desmos. Let me know, and I'll give you your assignment so you can go ahead and get started on that. On this assignment, if you do not have enough room to do the work, you're welcome to do it on a separate sheet of paper. So how would you get rid of those two groups? Squares. Yeah, so like this. Over here, it'll get rid of the key. Over here. You're not going to time anything. You're just going to write it. Okay. Let me show you guys how to put the cube root in on Desmos. For that, I think yours looks right, but it's not actually right. So when you go on Desmos down here, if you click Functions, it's way down at the bottom. There's this little button right there that has an in and a root. You want to use that. If you use it like an exponent, it's not calculating that correctly. So use that, and then you can put out here, put a 3, and then put what you need on the inside. Okay, so that's how you get to your cube root on that. Okay, just put your X and Y. So this is now an X. This is now Y. So it's not just a 2. What's it going to have with it? Multiply by 2. All right. Okay, nail it. Huh? You are good. All right. So, look. All right. I know. Let's restart. Yeah. All right. Yeah. When you've got the answer, let me know and I'll give you. Yes, good job. Get it? All right, which one did you get? Yes. Okay, so on the assignment, 1 through 4 is asking if those are inverses. Those can be done on Desmos, and you can just put a yes or a no. Or you can do them by hand. Either way, I don't care. But when you get down to number 5, it's asking you to find the inverse, so those are going to have to be done by hand. You can check your work on Desmos, but you won't be able to, answer it on Desmos. Okay. Beautiful. If I get in here. worksheet yet. Let me get to that too.
Hey, do I flip? I don't think it's quite.
You're gonna
Another way you can know that. Another way you can know is you'll get here, right here.
I got it.
Negative 2 is on this graph.
I'll say the first one.
Another thing to do is these two right here cross, but they don't cross on that red line. Right? So it's not moving. Alright, if you do not have your worksheet, raise your hand so I can get that to you. I would suggest the first 4 with Desmos. It should be A on that one that we just did. Does everybody have one now?
Alright, so first 4 I would do with Desmos. Some of you are zooming too far out and it looks symmetric, but you're too far out. Stay a little closer in for those.